Hey guys, in this video we have the Elegoo Neptune 3 Pro. So Elegoo is very well known for their resin printers and they are great value machines, but it's pretty cool to see that they also have FDM printers. So in this video we're going to unbox it, set it up, and do some prints. Hopefully you guys enjoy it. Let's get started. So let's take a closer look at the Neptune 3 Pro. So this is the box it comes in. We got a little picture here of what the printer looks like. There's no dimensions on the box, but the shipping label says 10 kilograms, which is about 22 pounds. And this is what we see on top. So we got soft foam, and we can see everything is nestled very nicely in it. So I'm just gonna pull this stuff out, starting here with this manual, which shows us what all the parts of the printer are, the packing list, and then installation instructions step by step, and there's only 5 steps. So yeah, this shouldn't be too hard, and then we're going to do some adjusting, and there's more information on how to start the print and things like that. So here we have another piece of paper that could be quite useful, especially for beginners. First thing here is checking your voltage, and we're going to do that later in the video. Then we got adjusting the rollers on the hot end and bed, which is quite important, and we're going to be doing that also. And on the back of it, we have a more detailed instructions on how to level the bed. All right, so here we have the screen mount holder. It looks like it's magnetic. Very interesting. We have our spool holder, which goes on top, and there's threads inside, which this just screws onto, and you can put it on either side. We got our power cord, US type. Looks like about 4 feet or so. And here we have a bag of things like tools, cutters, and things like that, and we'll go through this stuff in a second. So on the very top, we have the gantry, which is the upper portion of the printer. And as you guys can see, we got dual motors, so that's really nice for the Z-axis. And what's even more nicer is that we have a belt that tethers them together. So everything should be very nice and synchronized between the two. So if we spin one, the other one will spin together synchronized. So yeah, that's pretty nice. And you guys maybe can see we got a blue kind of finish on the channels, and not only that, we got quite an interesting design here which says create the future. Here we have the hot end itself, which also looks very interesting. It protrudes out quite a bit. You guys can see it's quite deep here. It is a direct drive, which is really cool, and we're going to take a closer look at all the details a little later in the video. So that's our top layer, and below that we have the base, which again very nicely nestled in all this foam. But I also see our screen looks like right here, which actually is quite wide in the hand, and on the back of it we can see this looks like where it magnetizes, and it is kind of like a portable removable screen that connects magnetically to the holder, which is quite interesting. It is a little wide, and you guys can see the bezels are quite large, so I wish it was a little smaller. Still nice that it is portable, but yeah, pretty neat looking screen. So let's go ahead and pull the base out. And right off the bat, I'm noticing that we have the PEI sheet on the top here, and it is a flexible sheet that's magnetic, and these are great. Usually Pro machines come with these, and this is a Pro, so it's nice that they included this, as these are very durable and quite easy to use, as the prints stick very well and then pop right off. So yeah, the printer looks quite interesting. There's some metal and plastic combinations, but again, we'll take a closer look at all the details in a bit. And that is everything for the box. As you guys can see, everything is super well packed and protected in all this foam. So let's move this out of the way, and we'll bring the base back in here. flip it around and see what we got under here. So yeah, very well constructed. We got large rubber feet that are somewhat squishy. It's gonna help a lot with noise and vibration. So we got the power supply on the back of the printer, which appears to be the typical 350 watt supply, but here on the front part, we have a cover that looks like maybe we can take off, which is where our main board is, and it'll be quite interesting to see what's under there. But before we do that, let's go ahead and see what's in this bag. So we do get some snippers, very nice. A spatula. It's kind of interesting that it's plastic and also the same kind that looks like is included in resin printers. We got our filament detector in this bag that we will need to install. We also got a very small little coil of PLA in white, and yeah, it's practically nothing. I'm not sure why they even included, but I guess it's good to do a little test or something. We also get a USB cable to connect from the printer to the computer, some zip ties, a clean out needle, and this is used to clean out the nozzle if it gets clogged. Here we have a little baggie of our USB adapter to micro SD card, and the card is in it. We also get a couple extra nozzles and a PTFE tubing, a bag of our hardware, which is the bolts we need to assemble the printer, and the last thing we have a bag of tools, a couple screwdrivers, Phillips flat, set of Allen wrenches, and a couple double-ended wrenches. So let's go ahead and grab the Phillips screwdriver that comes with it, as that's what we need to take these little bolts out. And actually they're not bolts, they're screws that hold this plate down. So let's see if we can pull it out, and it sure comes off. We got a pretty large cooling fan here for the main board, and yeah, quite simple but very well organized here underneath. All right, so this is the board that we have, and it looks like it's a ZNP Robin Nano DW version 2.2. So our stepper drivers are integrated, and we got heat sinks on top of them. All the plugs are hot glued. We got an ARM processor, and yeah, everything looks really good and crimped, glued. So yeah, overall very good vibe here from the Neptune. So let's go ahead and put this lid back on, and we'll flip it around and start the assembly process. So for step one, we're gonna put the upper portion, which is the gantry, down onto the base. And if you guys maybe can see, right over here, we got a few little cutout or slots that the gantry will sit on, and holes that bolts go through the bottom. And there are 4 M545s, which are the large black ones here in this bag with all the hardware, and you guys can see they are also labeled here. So quite easy and simple to find them. So we're gonna grab the gantry and we're gonna set it and down right in over those holes. Now this part could be a little tricky. However, you got to do it, and what's easier, so you can just raise it up and put the bolts in while trying to hold this whole thing, or maybe go off the edge of the table would be easy, or even use like a spool of filament to kind of hold it up so you can start the bolt. But yeah, it just goes underneath there, and it's going to come out here at the top, as you guys can see. So we're just going to line it up and start them. And we are going to need a wrench, which is the biggest one in the bag, and we're going to run them down. So we're just running them down and not tightening, because we need to do the other side also, and you want it to be loose so it can kind of give way if it needs to. So same thing here, we're just going to run them up, but don't tighten them yet. And the reason for that is because we want to run the x-axis here down all the way to the bottom. And the reason we want to do that is because we want the spacing between these two channels to be as close as possible on the bottom. So if you just grab the belt on the top and turn it, you can move the whole thing down, or you can just grab one of the couplers and spin them. But the belt is quicker, a little faster. So yeah, all we're going to do here is just go all the way down. And now we know we're really close to where it needs to be, so we can go ahead and tighten these bolts up really nice and snug. So tighten them up well, but not crazy, as that is the only thing holding the upper portion of the printer. All right, that should be good right there. Now, if you do want to, you can go ahead and also check, make sure these bolts on the sides are nice and tight, and that your printer is sitting flat, so on a flat table. If you do have any kind of wobble, what you want to do is you want to loosen these and on the other side, and then kind of push down on it where it levels out, and then retighten the both sides. So mine, I think, is pretty good right there. So I'm just going to check them just to make sure they're tight, and sure enough, on mine here, they're pretty snug, but did tighten a little bit. Same thing on this side. And that should be good. And now we have the top portion connected to the bottom. And we'll go to step 2, which is connecting the screen. And if we flip to this side, you guys can probably see the 4 holes there that are threaded. And that's where our screen mount will connect. Well, actually, it's just 3 holes. So we're going to need 3 of the 5 M420 bolts and the wrench. And I'm going to go ahead and start it here. So the wrench is not quite long enough. It's a little bit hard to get to, but the wrenches do have like this kind of rounded off edge, so you can go on an angle and still turn it, which is nice. I'm gonna pry it up here a bit so maybe you guys can see better, but yeah, I got the two started on top, and now this one here. And we'll go ahead and snug these up. That should be good right there. And this thing is quite magnetic. As I was putting it on, and notice that the wrench wants to magnetize to it, which means that our screen here should just fall right in and perfectly hold itself, and we can go ahead and plug that in right here. So yeah, pretty interesting. And you know, if you do want to pick it up and look at it towards yourself, it would be a lot easier to, you know, see what you're doing, even though it is at a good angle, which is quite easy to use here too. That is step 2 and 3, which is plugging it in. So for step 4, there's quite a few things going on. We're going to install the spool holder on the top, and also the filament detector, and a little clip there that guides the wire on the back. So let's start with the spool holder. I believe the spool holding part should be on this side, or at least according to the diagram, which mounts right here on the top. I don't know if you guys can see, but we got a couple threads there where these two holes will line up just like that, and we'll use the last two M4x20s to secure the spool holder. We'll snug it up right here. Also guys, we can check these bolts here, which is the main frame, to make sure they're nice and tight also, and mine are, which is great to see. And if you guys see this little wire here, this is for the filament detector, which is this guy here. So we have the detector itself that's mounted on a bracket, and then we also have a bolt that was in there that goes through the bracket into the filament holder. And so you want to put this on the side where your spool is. So because it's on this side, and because this wire, it'll go right here. So this bolt is made where it tightens, but it still moves around and pivots on there. And the plug itself needs to probably go to the front, because you don't want to route it through the back, as there is that belt there. So now we're just going to plug the filament detector in here, and that's basically for step 4, except for that little clip. And step 5 is just plugging everything in, which is not very hard at all. And we'll go ahead and start here in the back, where we do install the little wire holder, and does come with a little bolt, and that goes right here. If we look here on the side, we can see there's a wire that comes out from the bottom and then goes up, and the flat part of it has the end which plugs into the hot end. So let's go ahead and plug that in. And we'll go to the front here so you guys can see a little better, but there is a strain relief. But before we put it in there, we can go ahead and plug it in. So there's like these two little tabs that we have to separate if they're not separated already, and yeah, it simply just plugs in, and then they clip together to hold it. And now we can squeeze into the strain relief bracket, and that's how it holds it all together here. So now going back, we can use this clip here to secure this flat wire. But what you want to do is you want to move this as far away as possible to the very edge, and then you kind of know how much you need, and that's where we're going to secure it. I guess we're just going to kind of bunch them up like that. So actually that works out pretty good. It looks pretty clean. We're going to use the bolt that was included, clamp it down right here. And actually it moves in there quite easily, so if you need a little more or a little less, you can move it around. Yeah, simple as that. We definitely have enough slack, and the cable is nice and routed here. Now we do have a couple more plugs that kind of branch out of the cable, and they are labeled, and both of them say X. So the smaller plug is for the end stop switch, and the larger one's for the motor. So we got the switch here and the motor. So the motor gets the bigger plug like that, and the switch goes here. Just like that. So, and that's everything here for this flat wire. But if we look at the back, we got quite a few more things to connect here. So we got a few wires that go from the top down, and they go through the channel and then come out. And this is for the filament detector, and also a light up there. So we can go ahead and plug these in. And then also we have the motor here that we need to plug in. And that's everything here. And then the last one is the other Z-axis motor on the other side. And just like that. So the Y is all connected and all good. And that is everything with the wiring. And so for the next part, we need to look at the rollers and adjust if needed, and also check our belts and tensions on that. So we'll start here with the bed. This might have been easier to do it before installing everything, if you know, you'd prefer to do that, but you can easily reach it here. But what's going on here is that we got 2 rollers on each side. We got 2 stationary and then 2 adjustable. And so what I like to do is stick my hands under there and see if I can spin them, and they're both way too tight. And hopefully you guys can see that, but yeah, we got the adjustable ones here. So you're gonna need this wrench, and that's how we can adjust the eccentric nut under there. And so we're just gonna turn it a little bit to loosen it until we can get the roller to spin pretty easy. And actually I'm gonna take this build plate off so we don't get it greasy, and same thing for the back. So basically what you're trying to do here is get the rollers to be not so tight around the channel that it rides on here in the middle. So if you can't spin your roller in one spot, that means it's too tight, like a little burnout, and you need to loosen it. But if they're too loose, your bed's gonna wobble back and forth. So right now our bed is not wobbling, but our rollers are loosened up, so we should have a very smooth roll. So if you have any kind of jumping or stuttering in the bed, check your rollers really good. And also a good idea to check the belts. And we can see here the Y belt and the motor. It is pretty good. And our belt seems to be pretty decently centered. And going back to the front, also on our Y axis, you guys can see we have an adjuster here, and we can adjust the tension of the belt. So again, you don't want this to be too tight. So just slightly tight, but definitely don't over tighten it. And it's quite easy to do that. So feel it with your finger. Make sure it's, not too tight. But yeah, that feels actually really good. I think we're good there. So now we can go ahead and check our rollers here on the hot end. And these are actually perfect. They all spin easily, which is a great sign. And what's interesting here on this design is we actually have 4 rollers. Most of the time we only have 3, 2 on the top and 1 on the bottom. But this printer has 2 adjustable rollers on the bottom. And you would do this the same way. You would adjust it where you could easily roll these and kind of do like a little burnout. So if they're too tight, they're not going to roll easily. And if they're too loose, this whole thing's going to wobble. So adjust it to where you have slight tension, where you can still easily turn them. And once you get that, it should be nice and smooth. And also, we do have a belt tensioner for the X-axis here. Mine was definitely over tightened. I'm going to loosen it up a bit and see how that feels. And that's pretty good right there. So unfortunately, we can't see none of our pulleys here and how the belt is running on them. So we're just going to have to, think that everything's fine there. And it does feel all right. So I think I'm just going to leave it right where it is. Going back to the back, we do have rollers here on each side, and mine are all pretty much perfect. They're a little bit looser than they need to be, so I'm gonna tighten them up just a bit. So we got 2 eccentric nuts on the inside and then 2 stationaries on the outside. So these are not very critical, especially for the dual Z axes. As long as they're not binding or way too loose, you don't have to really do much with these. But I'm gonna tighten mine up just ever so slightly to kind of give it some friction. And that's pretty much it, guys. There's not much more to it. You're pretty much done with everything, assembly and adjustments. All right, so let's take a closer look at the Neptune 3 Pro. So starting here on top, we have our spool holder where the spool will go and then feed through the filament detector, and then out of there down to the direct drive extruder. So I like how the filament detector has brass inserts. It won't wear out. Nice detail there. So the top portion here with this logo is a plastic injected part, but we do have metal brackets here for the lead screws with bearings in them, and also the belt there, and that does sandwich all together here to the aluminum frame, which has these pretty interesting design elements on it that says create the future. Looks pretty good and quite unique. So flipping around to the back, you guys can see where we mounted our spool holder there, the synchronized belt between the 2 leads, our wires here that come out, one's for the filament detector there, and the other wiring is actually for some LED lights there underneath, which could be quite helpful as they can glow down onto the workspace. So all the frame pieces are metal all around. That's nice to see. Got the brass bushings there. Same thing here on both sides. This is where we put in our little wire clip holder. We got the X-axis motor, and it plugs there underneath, and our X-axis in-stop switch on this side. And going down from there, you guys can see our coupler, the Z-axis motors, same thing on both sides. But if we look over here, we can see there's a little cap there with wires coming out the bottom when we plug them in here, and that's the filament detector and the light, which traveled through here all the way up and come out right there. So looking at the back of the hot end, you guys saw we have 4 rollers, 2 stationary and then 2 adjustable underneath. And we can kind of see some of the components here. We have the heat break over there, the heat block. It does have a silicone sock on it. And then our little tip there where the filament comes out. We do have a dual cooling fan on each side that blows underneath. We'll look at the front side here in a second. But yeah, going down, we can see the Y-axis channel. It's actually a pretty nice clean channel, and it's also really wide, which gives the bed more stability. And this is our Y-axis end-stop switch, the Y-axis motor, and the belt here that travels through the channel. So at the back of the bed, we have strain relief for the wiring that runs into the back of the printer, and there's a few more wires coming out here. What's interesting is we have another plug here that's kind of covered up that says DC output 24 volts, 2.5 amps, which is interesting. I wonder if there's some kind of accessory to this printer that uses that. And if we go to this side, we can see here, this is where our power port is, and it is fused with an on and off switch here on the side. I like how they use this clip here to run the cable that goes all the way to the hot end. So going back over here, right underneath the Y-axis end-stop switch, we have the selector for the voltage. And this is quite important that you set this to the correct voltage. So depending on where you live, you're gonna have 115 or 230. So in the US, we have 115, but a lot of the Europe uses 230. So I'm gonna grab the flat screwdriver and switch that to 115. So yeah, make sure you check that before you power the printer on. All right, so going back to the front, let's take a closer look at the direct drive hot end extruder here. So it is quite deep, or wide, I guess, however you want to look at it, but it does poke out quite a bit. So there is a brass insert there for the feed, which is nice. All of this is plastic, including this cover. We have the 2 fans on each side for the parts cooling. There's a nice little Elegoo logo and some venting here up front, and this is kind of what it looks like. So I went ahead and took out 2 little bolts there on each side, and this thing should just come right off, which it does. And we can see the 2 axial fans. And then we have another large fan here underneath, and that's for the heat break, which is all in there somewhere. And on top of that, we got the direct drive motor for the extruder with the gear here. So yeah, and there's also a junction board on the back. And another thing that's quite interesting is we have a sensor here, and that appears to be leveling sensor, or the Z-axis switch, and it looks to be like a capacitive optical style, not an actual mechanical probe. So that'll be interesting to see how well that works. If you guys can see that little bolt right there, that hole, this is where you adjust the tension on how much pressure there is on the extruder gear. And if we slide this back on, you guys can see that it's still accessible through the cover. So yeah. So here on the X-axis, we have the belt adjuster on this side, and on this other side, we have the end-stop switch. So again, everything's covered up. It does look like there's a couple bolts that you can take off, get this cover off if you want to see how the gear lines up with the belt. And actually, it looks like here too, there's a couple bolts that might pop this off. So, but I wish that maybe they made a cutout where we can see, you know, if it does line up or not. But in any case, it does look nice and clean. And so going down from there, we have our bed, which is a 225 by 225 by 280 tall is the build volume, which is quite respectable for this medium format. And I love this PEI sheet. These things are great. They last forever and they're easy to use. And it is a steel sheet that flexes easy. So it's very effortless to print on it and pop the print off. And you guys can see the magnetic sheet underneath. Let's go ahead and put that back on. So we got the PEI, the magnetic, and then we got the aluminum heated bed, which by the way is not insulated, which is not a big deal for this size. We got the frame there, nice and thick. The 2 rollers here, you guys can see the adjustable eccentric nuts, and the 2 stationary on the other side. And then over here on the very front, we got the adjustment for the Y belt. Again, we can't see the pulley or anything from any direction, so I wish they would have made a little cutout here so we can see if we're running true or not. And another thing I'm noticing is that this printer does not have any kind of storage anywhere, so it would have been nice if they would have made some kind of storage, even a small one, but this one doesn't have it, which technically not a big deal, but it would have been nice to have one. So on the top here, we have the manufacturing label. We can see the name of the printer, the build volume, the machine size, the power it takes, 300 watts, and we got the weight of the printer at 8 kilograms. So going below here, you guys can see we have that USB port to connect from the printer to the computer. Then we have our micro SD card slot there. That's how we can bring in our files. And then over here we have the plug for the cord on the screen, which sits really nicely. And again, it comes off. It's magnetic. And we do have a sticker or a protective layer here that we need to pull off. That also reminds us to check our voltage. So overall, pretty nice screen. A little heavy on the bezels and the size, but pretty nice overall, and sits really cleanly here to the side. So not much going past here. We do have these nice large rubber squishy feet on 4 corners, and clean on this side, and everything tucked away really nicely, and the wire management here looks really good. So yeah, overall looks like a pretty solid printer. So for the next part, let's go ahead and plug it in, turn it on, home the printer, make sure all the motors and switches work. Also we'll preheat it and level the bed. All right, so I went ahead and plugged it in. Let's go ahead and hit that power button. And it does power up really quick. It says booting with the Elegoo logo. If you guys can see, hopefully. Alright, there it goes. So it took a little bit there to start. I don't know if it's a little bright or not. Maybe if I hold it to the side. But the screen is blue, as you guys can see. It's a pretty nice font. Good resolution. Easy to read. So we can see on the top there it says Neptune 3 Pro. And we have print, prepare, settings, and level. And on the bottom there we have the hot end temperature and the bed temperature. So let's click on prepare, and it does beep when you click on it. And down here we can see we're on move. We got temperature and extruder. So under move there's a all button here right in the middle, home. So I'm gonna go ahead and click that, and it should home. And we can see the X and the Y is working perfectly. And now the Z. Alright, also stops just at the right spot. So that's good to see. So let's go ahead and click on temp. And here it looks like you can preheat it manually, or click on one of these hot buttons, which we have PLA, ABS, PETG, and TPU. So I'm going to go ahead and click on PLA. Sure enough, it's going to go to 200 on the nozzle and 50 on the bed. So let's do a little hotter. Click on ABS. And that's going to be 240 and 80, a little too hot, maybe PETG. 220 on the nozzle and 60 on the bed. And I do hear some fans that kicked on in the hot end. Maybe you guys can see there, it's preheating pretty quick. So it looks like everything is working, which is a great sign. And the last button here we have extruder, which lets us control to load and unload. So because this is a direct drive, it's quite easy just to do it yourself here right on the top. But for the next part, what we need to do, let's go back here to the main menu, and we need to level the bed. And I don't know if you guys noticed or not, but we don't have any kind of knobs underneath the bed. So the bed is kind of pre-leveled, and we don't have to mess with that at all. All we got to do is the automatic bed leveling. And that's this level button here. So let's go ahead and click it. And so it's saying something about resetting to 0 action. So we're just going to confirm, and let's see what it does. Alright, so it appears that it was already auto-leveled from before, and it has all of its coordinates there. If you want to redo this part, you can, or you can just leave it the way it is. I do believe this button here will probably redo all of the measuring, so let's go ahead and try that. And then it says calibrate the bed. We're going to say confirm. So now it's going to do a calibration by measuring the whole bed across. So it does appear that they pre-calibrated from the factory, but you know, if yours is not, it's not very hard to just recalibrate it, or if you need to recalibrate it. And as it's doing that, you guys can see it's highlighting the numbers that it's done already. So we got 6 across and 6 deep, so that's quite a few points that it takes. Alright, and that is all of the points. Now on the screen, it's asking us to make sure that the nozzle is not too high or too low, and we can adjust that in the Z-axis offset. So we're just going to click on confirm there. And now we go back to that same menu we saw from the beginning, and we can see all of our offsets, and they did look like they changed quite a bit actually, or at least what I'm noticing. So it might be good to rerun your calibration anyways. What we're going to do now is we're going to adjust the offset. It's at minus 0.4 right now, and we got up and down here where we can adjust that. So you're going to need some kind of piece of paper, or I'm going to just use the sticky note. And what we're going to do is go between the nozzle and the bed. We're way too loose right now, so it's too high off. So we're going to bring it down. And you can choose the increments there. So as you get closer, you can go to 0.01. Yeah, I'm just going to continue to go down until we get close, which we are close now. So I'm going to switch to the 0.01 and go down slower from there. And yeah, because my Post-it note here is quite thin, I think I'm good right there. So I'm going to leave a decent gap. But yeah, you just want a slight drag. If you have a thicker paper, obviously you want more drag, but if you have something thin like this sticky note I have, you want very slight drag. But yeah, all we're doing here is setting the nozzle gap between the bed. And so mine ended up being minus 1.22. And once you set that, you're pretty much done with the bed leveling. So we can just go back. And that's going to save it into the printer, and you guys can see it's moving actually, which is great because for the next part, we can go ahead and put our filament in. And I'm just going to use this roll that I have, and we're going to grab our snippers and cut it on an angle. So it's much easier to feed it in. And looking at the top here, put the spool on the spool holder, and then run our filament through the detector. and there's a little blue light there that glows up, and then down into the extruder. And so this knob here releases the arm where we can feed it in. And so we can just manually push it right down through there until we can see it purge out the bottom. You can use in the prepare the extruder button here and have a certain amount at a certain speed purge, but it's much easier just to push it through yourself and a lot quicker. But yeah, we are pretty much done with leveling and putting our filament through. Let's go ahead and see if we have anything on this SD card, which by the way is an 8 gig, and it plugs in right here upside down. So we're going to click on print, and sure enough we do have a file there. But before we do that, let's go back, and we already went through the prepare menu. You guys saw everything there. Our settings menu, we have some adjustments we can do. We got language, temperature settings, light control. So we do have that LED light that glows from the top. So let's go ahead and turn it on and see. Okay, so it is on. It's quite a bit brighter, and you guys can probably see right here it's glowing very nicely. For this video, I'm probably not going to be using it as it is a little too bright and it will cast a shadow right underneath the nozzle, which is not going to help us. And the light is a little bit on the blue side, which I prefer more warmer light, but you do have this option if you want to use it. So I'm going to turn it off for now. So we also have fan control, motor off. So this releases the stepper motors. Filament detection. So since we have it, we should probably turn that on. We got factory settings, about the machine, and advanced settings. So the brightness of the LCD screen, actually that's pretty cool. We can turn that. Okay. All right guys, so I totally blacked myself out by accident. Now I have no idea what I'm clicking. So I'm going to try to restart this and see if it'll come back. It's crazy that they even give you the option to completely darken it out where you can't see anything. I hope that's not a problem. Okay, thank goodness it powers back up. So it's just for the time of that use case. So once you power it off, it resets it. Okay, so it does take about 5 to 10 seconds to load there. Not too long, but yeah, let's go back to the settings, advanced. So you can turn this down, which is nice, but be careful not to turn it down all the way. So we got the key sounds. So if you don't want it to beep, motor settings. So this is more advanced stuff here. Power loss recovery. That's cool that they have an option for that because sometimes printers in spiralized mode need that off. Happy to see that they have that option. So yeah, quite a few adjustments here and options to have in the settings. So let's go ahead and start that print that was included, and it's asking us to confirm, and there it goes. So it started. So once it starts, we'll check out this menu here and what it has to offer. And look at that, we actually get a preview of what we're printing. So I guess it's a little Buddha thing. So hopefully our offsets and everything is still good, and we can probably adjust that as it prints if we click on settings and adjust here on this tab here. We can do the offset right on the fly. So I'm gonna go ahead and leave that option open just in case we need to go up or down. And there it goes. So it kicked me out of that setting there. So far it looks good. We do have a little blob stuck to the okay, so it broke loose. All right, well, it's perfect actually. It doesn't need to go up or down, looks like, at least to what I can see. It's boogieing along. It looks like it's making a brim around the print, which helps it stick better. So let's go ahead and check out the menu here while it's printing. So this is what we see as the main menu as we start a print, and on the top it says printing, and it has the file name, the picture of the file, the percentage bar complete there, 1%. We got settings, pause, stop, and LED light, so you can turn it on and off here right on the fly. Very nice. So this is the time that passed. We got 3 minutes. The z-axis position, 0.2. We got the nozzle temperature and the target. Same thing for the bed there. The speed, also the fan, which just turned on to full power. So if we click on settings, you guys can see we got 3 main tabs on the bottom. So we're on filaments, and here we can adjust the nozzle temperature and the heat bed by choosing what you want. The temperatures here, we can also load and unload. We got speed settings. So we got print, flow, and fan. The print speed is 100, flow rate's 100, and fan at 255, which is the full speed. And then we have the Z offset, which we saw here. We can adjust that up and down. We also have the LED light control, power recovery mode, and filament detector here also. So yeah, all of your controls are here even while you're printing. Very cool. So yeah, I really like the layout. The screen looks really nice. So yeah, overall I'm really happy of how things are going with no hiccups, just printing straight out of the box. I'm gonna bring my microphone in so you guys can hear what the printer sounds like. All the fans are on, so it's actually on the quiet side considering that. And you can hear the motors a little bit when they're moving extra quick, but overall they're pretty much silent. So yeah, I would say this is definitely a quieter printer than normal. All right, so yeah, we're boogieing along and everything looks good. So I guess we're gonna let this print out and we'll see what it turns out like. All right, so our first print is done and it took 1 hour and 9 minutes. So you can click return or print again. Click return and goes back to the main menu. So the bed is pretty much cooled off. Let's see how easy this print pops off. Of course, it does have a brim on it, which, well, it still came off pretty easy on the actual print, but the brim, well, it peeled off too. Look at that. So yeah, the PEI sheet obviously works well, and this is one of the best materials you can have for 3D printing. But yeah, with the brim pulled off the print, I can tell you guys right away that I am very impressed with it. The layers are sitting extremely even, and just look at those reflections. Very impressive. So this little print here was sliced very well, and the printer did an excellent job printing it out. So yeah, very happy with this first print, and I think we're off to a really good start. So for the next part, let's go to the computer, see what's on the SD card, and slice our own print. All right, so we're at the computer and I got the SD card plugged in. Let's go ahead and open it up. So we got a few folders and a file, a G-code of the Buddha we printed. So the first folder is a manual in PDF form, which is basically the same thing you get in book form. So here we have the machine parameters and the breakdown of all the parts of the printer, the packing list, things like that. So yeah, so the next folder is software and drivers. So Elegoo looks like has their own modified Cura slicer, and they also include a PDF of how to get started with that. But since I already have Cura installed, we'll just use that. The next folder is model, and actually there's a tool holder that you can print out. So I did complain that there's no storage, but looks like they do solve that with this tool holder bracket. And this is what it looks like. You could print this out and organize your tools on it. Very cool. And the last folder here is a video of the assembly process from Elegoo, which could be helpful to assemble and get started. So let's go ahead and open Cura, and this is what it looks like. So if you're using it for the first time, it'll prompt you to add a printer. But I'm going to click over here where it says Ender 3 Pro, and we're going to choose either to add a printer, which if we do that and we go to non-network printers, we can see here that Elegoo is not part of the list, but there's one printer that reminds me would be the Ender 3 S1 Pro, and I already have a profile for that, so I'm just going to use that. But I'm going to go to manage and machine settings and change the dimensions to 225, and it looks like we already have 280 set on the Z height. And these settings should be very similar to what we need. So let's go ahead and drag in a Benchy. And if you click on it, you can move it around, or you can use these arrows here. And on the side, we got a navigation here between move, scale, and you can type it in here in percentages or millimeters, or just pull on these things here. So we also have rotate, mirror, and a few other options down here. So the main thing is going to be over here with our profile. And if you click on these little dots here, you can see I'm on advanced. And this is where you want to be. So let's go real quick over these. So I got the layer height at 0.2. Wall line count, I changed to 3 as it makes better walls. Top layers at 5, fills the gaps on top better. Fill gaps between walls, you can choose that to be everywhere. I choose nowhere. Infill density as 15 to 20 is about normal. Printing temperature 260 on the bed. 50 millimeters is what I usually print out. Most prints. I do slow down the initial layer to 15. Under travel, retractions are enabled at 1 millimeter, 40 millimeters a second. Combing mode not in skin. Cooling is pretty much standard here for everything. This is your support button here if you're going to use supports. For build plate adhesion, I like to use skirt as it prints straight to the build plate with 3 lines around it and then starts printing the print. But you can also choose brim, which is quite a few lines around touching the print, helps it stick better. And then raft builds a whole raft underneath the print, which wastes a lot of time in material. And then under special modes, we got spiralized mode here. And if you click that, it'll print a few layers on the bottom and then 1 layer all the way around. So good for like vases and things like that. And we'll also try this. But yeah, that's pretty much it. The only other thing that I like to turn off, and if you go to expert here, clicking these little dots and go down to travel, scrolling down a bit, you're going to see here retract before outer walls. I like to turn that off as it makes the walls a bit nicer around small areas that have a lot of retractions. So let's put that back to advance, and that's pretty much it, guys. So we can go ahead and slice this print, clicking on the slice button, and it says it's going to take 1 hour and 52 minutes. And then we can save it straight to the removable from here since we got our SD card plugged in. So we saved that. So I'm going to double click or right click and clear the build plate, and also throw in a calibration cube and slice it. And that's going to take 35 minutes. I'm going to go ahead and save that, and we're good to go. And now we can take the SD card to the printer and print these prints out. So hopefully this little quick overview of the slicing was helpful. Alright, so we got the calibration cube and the benchy printed out, and yeah, the bench actually took 1 hour and 44 minutes, which is less than the slicer showed us. Let's look at this cube here. So the lighting is a little bit hard here to show you guys, but there we go. So this is our X, and you guys can see how well that turned out. That is excellent. And then we got the Y. Also very, very nice. So we don't have any kind of ringing or ghosting, and it looks really good. The X wall and the Y wall. I had a little blob there or something, but you can see there's a little bit more ringing on the Y, and the X practically doesn't have anything. So yeah, very nicely laid down. The bottom, this is what the bed leaves, kind of a crinkled look. And the top, also very nice. So yeah, impressive for the cube here. The layers went down beautifully. So let's look at the benchy. And look at that, guys, it just pops right off. So yeah, the PEI works perfectly. So with the benchy, I'm really impressed because as you guys can see, hopefully here, I don't know the reflections, but look how nice the layers went down. It's usually never this nice. So this printer did an excellent job. And you guys can see there on the side even, it's just beautiful. And if we go to this side, you can see there's a little bit more layering, and this is our Z seam. So depending on the lighting, you can see some of these layers here, but yeah, that's just the lighting actually, it's not there. I'll show you at a different angle. There we go. So yeah, and because we use this black area, we can see every little detail. And yeah, the box in the back looks good. The windows are nice. There's nothing sagging almost at all. So great cooling. The top looks great too, so nothing to complain about this benchy, and I would actually say that it's above average. So yeah, this printer's very impressive. And when we printed out this little Buddha print here, I was convinced that this thing was going to do great. And sure enough, the benchy and the calibration cube here proves that. So yeah, very good start here with our own prints also. So I'm going to go ahead and slice some more models. And we'll also print some TPU since we have direct drive. Also, we'll try out spiralized mode. And maybe I'll do something a little bit hotter like ABS and see how that goes. Alright, so these are all the prints that we printed, and we did quite a few different kinds of prints with different materials. I have to say, guys, I'm pretty impressed with this printer as it did everything extremely well. And not only that, it seems to outperform printers double its price and have more features, which is quite incredible. So we've seen the first print, we've seen the benchy, the calibration cube. Those turned out really good. So let's check out this little frog, which is printed in PLA, kind of like this matte filament, and you guys can see this thing turned out really, really good. The way the layers go down are really accurate and precise, and there's no stringing or anything weird. And we're printing at 0.2 layer height, 50 millimeters a second, and retracting 1 millimeter at 40 millimeters a second. So yeah, great settings for this printer looks like. And this little frog is hard to print around these paws here, which gets a little messy, but this printer did an excellent job. So yeah, very impressed with this one. The next print we got here is a Squirtle, which is like a turtle slash squirrel. It's kind of like a polygon, and you guys can see how nice all the flat spots look, and really even overall and just very clean. And around the fingers here and the eyes, you guys can see how clean that is. Again, very impressive with this printer, and the bottom sticks really well and pops off when you're done. Here we have another PLA print, also turned out excellent. So normally this area here would be really messy kind of, and the helmet around the edges pretty bad, but on this one they're pretty much spot on. So yeah, again, very nice layer adhesion and a great result here even for these smaller fine prints. And you guys can see these little ridges on the shoes was the only thing holding to the bed, which held on perfectly and then popped right off. And for our last PLA print is this gear, and this is kind of like a test to see if the printer is accurate and prints perfectly round. So this is a functional print, and these are little gears that are separately printed, and it should move. Let's see. All right, so I just broke it loose and there it goes. So this would be considered excellent, because most printers, you would have to use the Allen wrench here in the middle to break it loose, because either too much stringing or they're fused together between the gears. But for this print, it's practically perfect. I mean, I'm impressed, honestly. As you guys can see, perfect for prints like this that are functional. And so all those were PLA, but I wanted to try something hotter, which I did ABS, which are these wheels here. And I preheated the bed at 100, which was not an issue at all. And then after the first layer, stayed at 90, and the nozzle was at 260. You guys can see the wheels turned out perfect. So these are for like a drift car. And yeah, printed ABS, you guys can see how clean the layers are. And we had no issues whatsoever with sticking or warping or anything like that. So there is support, and let's see how easy that comes off. And look at that. Perfect. So yeah, incredible printing here, even with ABS. I'm pretty blown away with how this printer is just good at everything. Well, speaking of that, we have TPU printed in spiralized mode, which is pretty crazy because TPU is quite soft. And you guys can see the layers look excellent as usual, except for when we get to the top. And there's a reason for that. It's got like a little bit of blobbing and roughness to it. And that's because of the power loss resume in spiralized mode makes the printer pause. And we're going to go a little detail into that when we talk about the spaceship there behind us. But this little rocket was printed in TPU, and it turned out pretty much perfect. And you guys can see that it is TPU. You can just fold it up. So yeah, pretty cool. And it bounces right back to its original form. And I really love printing TPU because prints are pretty much indestructible after that. You really have to, you know, rip them or have a pretty large force before they break, which is good for like printing things that require a lot of handling or movements, things like that. So, but yeah, this printer did an excellent job with TPU, which comes to the rocket here, printed in PLA, and this is 280 tall. And I noticed that the printer can go a little taller, but this strain relief here starts to kind of butt against the top. So 280 is definitely the max. And so this spaceship here is spiralized mode, and you guys can see the bottom looks pretty much perfect. And look at those walls, guys. That is incredibly smooth and straight. And there are no issues whatsoever with this print. It looks incredible. So yeah, quite amazing. Now, if we get to the very top, here you guys can see we have the same kind of blobbing we had on that little rocket. What this is power recovery mode. When active, doesn't let spiralized mode print very easily, because the way power recovery mode works is that it tries to remember each layer the nozzle goes up. So if you lose your power, it can resume from there. But in spiralized mode, it's more like one big layer from top to bottom. So there's a lot of memory required for remembering where the nozzle is. So every time it moves, it has to remember that. And what's cool about this printer is that you can turn that off in the settings while we were printing, and also in advanced settings we have a power loss resume toggle here. So if we turn that off, we can print spiralized mode in perfect printing without any kind of hesitations or pauses like we did up here. So what I did was I turned it on, and that's what it started doing, and then I turned it off, and it finished perfectly as it did the rest of the print there. So yeah, again, this printer has features kind of like the power recovery on and off toggle that most other printers don't, which I really appreciate about this thing. And actually, guys, I forgot totally about this print. It's also printed in PLA, and this is chainmail. And you guys can see it did a perfect job. I printed a small little sample here so you guys can see that it does very well with lots of retractions and quite small, tedious kind of prints like this. Again, anything I throw at this thing, it does an excellent job. And also, I forgot about another print, which is right over here. It kind of was out of my sight underneath the bed there. And this print here is also in PLA, has lots of pieces here that combine together. And the thing about this one is it printed out very nicely, except for the filament was very stringy. So this is an older filament that I have that's probably about about 4 years old or so. So I think it's just kind of lost cause at this point. And the reason I use this filament is because no matter what filament I use for all these other prints, they all turned out perfect, which some of the filament I had was quite old, and I was impressed. Like on this astronaut here, this bronze usually does pretty bad on most printers, but on this one it did very well. So I pretty much threw the worstest filament I had at this printer, and this is what turned out. Yeah, it still did great. It didn't mess up. All the little feet stuck to the build plate. So again, the PEI sheet works perfect. A great print overall if it wasn't for the stringing because of how old it is. So yeah, I guess what I'm trying to say is the more I use this thing, the more I was impressed with it, and the more I wanted it to be my main printer for just about anything. Because it does so well from PLA to ABS, I feel like overall it would do great in pretty much any printing situation. And it really feels like a complete and polished design that was very well thought through. Overall, I really like the look with this nice touches. All the materials are great. We got smooth channels, dual Z-axis motors, tethered with a belt. The filament detector works perfect. The direct drive extruder hot end is very unique designed and seems to work flawless. The printer is quiet overall. The cable management is great. I like how we have adjusters here for the X and Y. A very respectable 225 by 225 by 280 tall printing volume. The flexible PEI sheet works perfect. And by the way, our out of bed leveling sensor there has been working perfectly and seems to be just as good as those probes, or maybe even better, because I got a perfect bead every time on the first layer. The removable touchscreen that's tethered on a wire here is very convenient, as you can pick it up and look at it, and it makes it more easier and funner to use. And also this little magnetic tray that it sits in. Now, a couple things that could be a negative is there's no tray. You can print out that print that's included to store your tools, but I still would have liked to see a tray here. And another thing that I noticed is this SD card slot is a little bit hard to get to, and also a little tedious to put it in there, as it doesn't align completely perfect with the board. Other than that, guys, I really love this printer, and I feel like this is a great one, especially for beginners out there, or even somebody that just wants a printer that's easy to use and fun. So yeah, I'm giving the big thumbs up for the Elegoo Neptune 3 Pro. And if you are interested in this printer, I would highly recommend it. So links will be in the description. Check it out. And if you guys did enjoy this video, then hit that like button. If you want to see more videos like this, check out my 3D printing playlist. There's quite a few interesting things there. And also, if you can support my new channel called Just Print, I would really appreciate that, as eventually I'm hoping to move all my 3D printing there. Thanks for sticking around. Thumbs up to you for making it to the end. And as always, thanks for watching, and I'll catch you on the next one. Peace.